Welcome to the Check Your Understanding for 8.1b. As part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA out loud. Based on the responses, Ellery said she was 90% confident that the interval from 3.14 to 3.52 captures the true mean GPA for all students at her school. So the goal is to estimate a parameter, the true mean GPA. Ellery must have gotten a point estimate, which would be right in the middle of 3.14 to 3.52, and she constructed a 90% confidence interval. Interpret the confidence level. So when you're interpreting a confidence level, you're interpreting what does this 90% mean? Because we would have a different interval if it was a 95% confidence interval or an 80% confidence interval. So what does that 90% mean when this is like a disclaimer? And if you were to take many 90% confidence intervals, if you were to make them, like if Ellery were to do this again with a different sample, she'd likely have a slightly different interval. But if you were to do this many times, about 90% of them will capture the true mean GPA. Remember, the true mean GPA doesn't change. It exists. It's this number, this mu. And this is our best job at estimating it, but you'll have variability when you sample. When you sample, you're going to get different point estimates from sample to sample, but if you were to construct many of them, because of the way this is constructed, about 90% of them will contain whatever the true mean GPA is because of that nature of the sampling distribution. Explain what would happen to the length of the interval if the confidence level were to increase to 99%. So a higher confidence will mean a bigger margin of error. You're going to capture that true mean in approximately 99% of confidence intervals. So it's going to widen. How could a 90% confidence interval based on a sample size of 200 compare to the original 90%? So the original 90%, it was a sample of 25. So we increased the sample size, which we know is going to decrease the variability in the sampling distribution. Because in the sampling distribution, to get the standard deviation, which is a measure of variability, you divide by the square root of the sample size. So your margin of error is going to be much smaller. And your interval can be much narrower and still have a confidence level of 90%. It would be more narrow because an increase in sample size decreases the margin of error. Describe one potential source of bias. Now remember, an interval, like a margin of error, isn't going to account for bias. It's not going to fix if something went poorly in the collection of the data. So the only way to get rid of bias is to scrap your data and start over with a different strategy, different sampling design. So describe a potential source of bias. Students might not tell the truth about their GPA. Remember, they're self-reporting this number. So anything that would cause the responder to not be truthful is a form of response bias, whether it's like a sensitive question or the way it's being answered. Cool. Hopefully this was recording